Okay, today, agri-science students, we're going to start looking at the different scientific principles of environmental biotechnology or environmental science, not biotechnology. We already did that part. We are going to break this down into water, soil, forestry, wildlife. So we're going to kind of break it down into different areas. And this week we're only going to get as far as looking at water. And then next week we'll pick up with soils and wildlife. But when we're looking at water, a couple of terms that you need to be familiar with. The first one is potable water, and basically this is drinkable water. Now we know that the earth is majority water. There's much more water than there is land, but all that water is not potable. We can't drink salt water, for instance. So this is drinkable. It's free from harmful chemicals and organisms, and most of your water that we have on Earth is not potable water. It's not fresh water. So you do need to be familiar with that term. Water itself is what we call a universal solvent. Um, there's a lot of things you probably should not mix together. Um, you know, Baking soda and vinegar. If you mix those together, you're going to get a big sloppy mess. Um, Chlorine and ammonia. If you mix those together, you're going to get a gas that could knock you out and is toxic. So, there are certain things we don't want to mix together. However, water typically is what we call a universal solvent. Um, you can pretty much mix water with almost everything. It's going to dissolve or otherwise change most other materials. It may dilute it, but it is typically going to change the way that it looks, acts, or reacts. Another term is the water cycle, and I know that you have been looking at the water cycle in your science classes ever since you were in elementary school. But basically, when we're looking at the water cycle, we're looking at the entire cycle between um, precipitation, when it rains, snows, and then it's going to fall to the ground. It's going to be absorbed into the ground or into other bodies of water, and then eventually it is going to evaporate. It will condense and it will fall again in some form of precipitation. So, when we're looking at the cycling between different water sources in the atmosphere and surface areas, you were talking about precipitation, which we're basically looking at rain or snow, and the fact that the evaporation piece is what's going to actually cause it to go from a liquid state into a gas state, which will eventually condense and precipitate again. Next term is a watershed. And a watershed is going to be a large area in which water is absorbed from rain or melting snow. And it kind of acts like a water system, a storage system for water. A watershed is more or less where water gathers. And so, as I'm recording this video, the remnants from Hurricane Sally are outside and they're pouring down. And so, if I were to go and look for areas that might be a watershed, I'd be looking for things like ponds. I would be looking for things like big puddles and rivers and streams and areas that more or less where that water goes whenever it rains. Where is it going to be stored? Basically, this is where excess water is going to be, and it will typically be released throughout the year as we have this water cycle. The water table is the level at which below a particular level, um, the soil itself is going to be saturated with water. If you dig down deep enough, you're going to find water. Now, up in our part of the world, because we are on a little bit higher elevation up near the mountains, the water table is going to be high. And so it's going to take you quite a bit to be able to dig down to find water saturation in the soil. But if we were to travel about 6 hours east of here and we were to be near the coast, and you start digging in the sand on the coast, it doesn't take you very long digging before you get to water. And so the water table basically is just the level at which the groundwater is found, where the groundwater actually starts to be saturated in the soil. So the water table here, much higher than what you would see out in the coastal region of the state. All right, we're going to skip this assignment. Basically it was just asking you to draw the water cycle, but we can take a look at this picture of the water cycle right here. It kind of does a good job of helping to explain how all of this stuff works. So let's take a look at some resources of water. Some different types of groundwater. So this is water that's going to be found in the soil. All water is not just falling from the sky all the time. There is water that is typically found in the soil, even though we don't think about it being there because we're walking on solid ground. Capillary water is water that plant roots can actually absorb. These are very small molecules of water that are available for plants to be able to absorb into their root hairs. Free water or gravitational water is water that drains out of a soil after it's been wet. If you ever water a potted plant, for example, you can water a potted plant and you can pour a gallon of water into it, but only so much is actually going to stay in the pot with the plant. Some of it's going to drain out. And so that free water or that gravitational water is what comes out after we've put as much water as we can into the soil. Hygroscopic water is water that is just held so tightly that the plant roots just cannot absorb it. And so that's a big issue in our area because our soil tends to be very clayey, and because of that, the particles of soil are very compacted together, and so it is much more difficult to grow plants in a clay type soil than it is in a soil that you would find maybe toward the middle or eastern part of the state where the water is more readily available. So, growing plants and water have a tremendous amount to do with one another, and you can't do one without having the other. So you have to have that water in order for the plants to be able to grow. And so it has to be available for the plants. We need to think about the idea of improving water quality, conserving water. I have to admit that when I brush my teeth, sometimes I forget to turn off the water, and it's usually about halfway through before I'm like, dang, I forgot to turn the water off. When my kids were little, and y'all may remember this cartoon, there was this cartoon on Disney Junior that was called Special Agent Oso, and he was this little yellow bear looking thing, and he would remind kids that they were supposed to turn the water off whenever they brush their teeth. And so every time I brush my teeth and forget to turn the water off, I think about Special Agent Oso. So those lessons that you learned as children can stick with you, or the lessons that you learn as a parent because your children were learning them can stick with you too. So we do need to think about the idea though of conserving water, because yes, all the water that's here was here. However, water has to be filtered. It has to be clean. We have a decent supply of clean air or clean water in the United States, but there are places around the world that don't. So we need to make sure that we are paying attention to the aspect of oil, water pollution, and how we can actually reduce soil erosion. And we're going to talk more about both of those as we go on. We probably should have just done soil and water together because they do work together so well, but we will be talking about soil next time and how water has such an effect on soil. Last slide in the water section. Oh, there we go. It talks about turning off the faucet while you're brushing your teeth. So whenever we are looking at the idea of using water, but also preserving water, we need to think about how we can do that. Yes, it is available for us to use. It's necessary for us to be able to live. It's necessary for many of the things that we do on a daily basis, but we can do a better job of taking care of it, like turning off the faucet while we're brushing our teeth, as Special Agent Oso told us. Disposing of household products carefully and appropriately so that they are not going to pollute any groundwater or any water resources. And then caring for lawns and gardens carefully. And we'll actually get into that when we talk about the erosion aspect of things. Whenever we're talking about soil, if you're in cohort A or B, we will watch a segment from Dirty Jobs where they're actually gluing the side of a mountain together in order to try to avoid some soil erosion. And we'll be looking on campus for some erosion or some signs of erosion. So we'll talk about the water aspect this time. Next time we'll talk about the soil aspect and how both of those work together and can cause great problems for the environment if we're not very careful. So if you have any questions about water or the water cycle, make sure that you ask those questions, and next time we will be looking at soil and the effects that water actually have on soil. Talk to you next time.